Hello everyone, we are Team 47. We tried to develop early prediction deep learning model for mechanical ventilator requirement. COVID-19 struck the world medical system, and we faced to the terrible situation that many people died without adequate medical care because of shortage of ICU bed and mechanical ventilators. In ICU, deciding when to put a patient on a mechanical ventilator is crucial for the survival of patients. And the mechanical ventilator duration is one of the most important issues for decreasing ICU mortality. Precisely predicting mechanical ventilator requirement is beneficial in various aspects. Firstly, we can calculate the necessity for ICU management of patients. And secondly, we can efficiently allocate the mechanical ventilator supply to each doctor based on the calculation. We used the MIMIC4 and MIMIC aspect ray dataset. By using SQL, we extracted demographics such as comorbidity, medication use, and chest X-rays and measurements. Our goal is to predict the need of mechanical ventilator. To do this, we used the ventilator duration table of MIMIC4, including ventilator setting information and chart events for defining the start time of the mechanical ventilator. In the final dataset, we excluded coronary care unit, cardiac vascular intensive care unit, and surgery-related mechanical ventilator applications. Here you can see the final dataset number of cases. We used the light GBM for EHR data model, and CNN model with LSTM for chest X-ray data. Lastly, we train our final model using both EHR features and the hidden representations extracted from chest X-ray using our auto-regressive CNN. We observed a slight increase in the performance when the features from both EHR and CX are incorporated. Here shows baseline case characteristics of patients received mechanical ventilator and not mechanical ventilator. In terms of socio-demographic features and comorbidities, we found some differences and similarities in these patient groups. Here is the result of our model performance. In predicting need of mechanical ventilator, EHR model itself had very impressive results. This EHR model itself showed 0.959. Combining CXR to this model even increases this result to 0.96. We checked feature importance and found that age was the most important of prediction. Shapley value showed that case classification were affected most strongly by heart rate, mean BP, and GCS. To validate the learning capability of our autoregressive CNN model, we added artificial watermark only to positive samples. Our model could quickly capture the pattern of the watermark. In discussion, we would like to highlight 3 points. Firstly, we successfully predict the mechanical ventilation by using EHR data. Secondly, prediction by CXR only had lower performance, but adding it to EHR prediction showed a slight enhancement. This may be due to 3 reasons. Because this may be due to too heterogeneous spectrum of ICU patients, and because this may be due to change of CXR follows after the clinical aggravation, or this is because underlying lung condition is not reflected in single CXR. Finally, we want to discuss our result can help efficient allocation of the necessary medical ventilation supply to each ICU and hospital. After this research, we will apply the model to subgroups with narrow spectrums, such as sepsis, pneumonia, or pulmonary disease. We will also add algorithm that predicts mechanical ventilator winning failure to make high-quality model. Finally, we hope to commercialize our model to real-world environment after some external validations. Thank you for listening.